Today we'll be looking at the salt copper 2 acetate. Copper 2 acetate, which I'll just call copper acetate for the rest of this video, is a dark greenish blue water-soluble salt. Copper acetate is used as a reagent in organic synthesis to couple terminal alkynes with an interesting byproduct of copper 1 acetate. Copper 2 acetate is also used as oxidizer in the Barfod test in order to test the presence of monosaccharides by oxidizing the monosaccharide aldehyde to a carboxylic acid while also precipitating out copper 1 oxide as a byproduct. Copper acetate is also a precursor to the dye Paris green, which contains arsenic and as a result is highly toxic. To make the copper acetate, the procedure is simple. You'll need 0.613 grams of basic copper carbonate that was made in a previous video, 1 milliliter glacial acetic acid, and about 5 to 10 milliliters of distilled water. The glacial acetic acid can sometimes be sold at beekeeping stores, but it's not very easy to come by. Vinegar and other concentrations of acetic acid can be used in place of glacial acetic acid, but it will require more time to boil off the water. The first step of the procedure is to put 1 milliliter of glacial acetic acid into a 50 milliliter beaker alongside 5 milliliters of distilled water. You should typically always add acid to water and not what I did here, as concentrated acids can sometimes cause boiling if the water is added to the acid. Next, basic copper carbonate is added slowly to the beaker to reduce the possibility of foaming. I didn't get any foaming here, but it's more likely if the reaction is done at a larger scale. To also note, I got impatient and added a few more milliliters of acetic acid and got worried about solubility, so I also added some more water, but this is unnecessary and I do not recommend this. The reaction that's happening is shown here where the basic copper carbonate is reacting with 4 molecules of acetic acid that form copper 2 acetate while also forming CO2 and water as byproducts. The reaction is then determined to be complete when the solution becomes clear and no more solids are left in the solution. Once the basic copper carbonate was fully reacted, the solution is then heated to boil off the remaining water and acetic acid. When the solution's volume starts to get low, crystals of copper acetate will start to form, and the solution was then taken off the heat when only a little bit of solution remained. The remaining solution was then filtered and allowed to dry to attain 0.566 grams, which correlates to a percent yield of about 51.1%. This yield should have been quantitative, but due to my small scale and copper acetate solubility in water, loss during transfer added up quickly, and washing out the beaker would not have been possible without greater loss of yield. I don't have any real plans for the copper acetate, except for my copper compound collection, but if you have any ideas, please leave a comment below. I hope this procedure was useful, and thank you for watching.